I think I am live now. Can anyone confirm if audio and everything is fine before we get started? Okay, let's get started. I was able to solve A to D, so I will discuss the first four problems. Like I had some ideas on E, but like in context, I did not had enough time. I tried solving it for last 1 hour or so, and like, I did not got an issue. But I will discuss what I was trying to do over here, and pretty much that would be the agenda for today's stream. Let's get started. Turtle and Piggy are playing a number game. First, turtle will choose an integer I such that integer x such that x is between L to R, where L and R are given. It is also guaranteed that 2 times L is less than equal to R. Then Piggy will keep doing the following operations until x becomes 1. Choose an integer p such that p is greater than equal to 2 and p divides x. Set x equal to x by p, the score will increase by 1. The score is initially 0. Both turtle and Piggy want to maximize the score. Please help them calculate the maximum possible score over there. So like I missed out the constant that 2 times L is less than equal to R, and then I did some things over there and ended up even resubmitting the code before I realized that this is the constant. Like initially I was solving where it was given in general like L less than equal to R, and I did not have much proof for it as well. The crux of this problem is like let's say we have an integer x. What is the maximum number of prime factors we can have? Like if you see like the answer is essentially like the number of prime factors, like maximum possible value of the count can be the number of possible prime factors here. So like, and like if there are k prime factors, I am assuming that repetition is allowed over here. So if there are k prime factors, each number is greater than equal to 2. So like the number with k prime factors will always be greater than equal to 2 to the power x. Or other way around, if you have a number y, then maximum number of prime factors would be less than equal to log 2 with base y. The reason is because like if there are 5 prime factors, then each of them would be at least greater than equal to 2, right? So if you multiply all those 5 numbers, the minimum possible number you can get is 32. Or other way around, like if a number has 5 possible, other way around, let's say we have a number 60, then like log 2 with base 60 is around 6. So like if the number has 6 prime factors, then the minimum possible value would be 64 there, but your current number is 60. So like the bijection holds over here. Like for example, if number has 5 prime factors, like I am not counting distinct over here, then number is greater than equal to 32, because 32 is 2 to the power 5. Because if you multiply 5 numbers and if all of them are greater than 1, then the minimum possible number you can get is 32. other way around, like if we have 60, 2 to the power is greater than 60. So like 60 cannot have 6 prime factors. So like the crux of this problem was like, and like now you can try out inequalities, like you can try to find like what is the number of prime factors L can have, maximum prime numbers L can have, what is the maximum number of prime factors R can have. And like that log 2 be R equal to X. Because we have constraint like 2 to the power R, like it would happen that L would be greater than equal to 2 to the power X is greater than equal to R. And essentially like that was the solution for this problem. Like to summarize again, like we first find the how many maximum prime factors, like let's say number 60 can have. 60 can have at max 5 prime factors. Let's say R is 60. So answer can never be more than 5. And like 2 to the power 5 is equal to 32. And because we have 2L is less than equal to R, like 32 would always be greater than equal to 30. So like essentially that was the solution over here. And like I missed this important constraint that 2 times L is less than R, and like I ended up doing a lot of things over there and even resubmitted at one point. So essentially that is the solution. So we start with number R. While R is greater than 0, count plus plus R less equal to 2. And at last print whatever count we have. And like we don't really need L over here. Or like 1 second, R must be greater than 1. Let me see. Yes, R should be greater than 1 there. And any questions on the first problem before we move to the second problem? Yes, essentially like what that is in the chat as well. There is always a power of 2 in any range from x to 2x. And like essentially like any questions, like I did not realize that this is the constraint there, and to be honest, I found this problem really hard. Like I was surprised when I saw a lot of x's. Okay, probably like anything which I should repeat for the first problem, like I will take 30 seconds, otherwise I will move to the next one. Like the idea, like one thing was like realizing like if log 2 with base R is R, then 2 to the power R, like L is equal to log 2 with base R, then 2 to the power L will exist in the constant because of this constant, and 2 to the power L will have L different prime factors, and that's why the answer is L. Okay, I will move to the next problem. There is a sequence A0 to AN, like infinite length, where AI is I initially, and for every second each element of the sequence will simultaneously change to AI, like basically takes OR of two neighbors factors over. Turtle is asked to find the value of AN after m seconds, in particular m equal to 0, then he needs to find the value of AN. He is tired of calculating so many values, so help him find, like n and m is given to us. So like let's say like we represent AI is range of some number from L to R. At m equal to 0, like this range AI would be from all the numbers from I to or of all the numbers from I to I. And when you have m equal to 1, AI would be Li to Ri along with or of Li minus 1 comma Ri minus 1 and or of Li plus 1 comma Ri plus 1. Or basically what you will see is like at m equal to 0, every number is the or of I from I to I. And when you have every number like every number I would be or of I to I plus 1. At m equal to 2, like every number would be or of I minus 2 to I plus 2 and so on. Like LIRI was basically a set of numbers which were or which we should take from Li to Ri was the case. And like this is what, because like when you take the first time you will also take I minus 1 and I plus 1 for the first time. And like here the number would be from I minus 2 to I, and here the number would be from I to I plus 2. So like two more number adds up and so on. At mth instant, nth number is or of all the numbers from range n minus m to n plus m. Any questions on this observation so far before we try to find like how to find the or of range from n to r? Okay, clear? So like one thing we can probably, okay, yeah. So now I have two numbers L to R and I need OR of all the numbers in range L to R. Like OR is bitwise OR, which is also defined as this operation here. So like the idea is like let's look at like what the sequence is. First number is 0, second number is 1, 0, 3, 4, 5, 6 at m equal to 0. When you have m equal to 1, like the first number would be OR of 0 and 1, second number would be OR of 0, 1 and 2. And so on. At m equal to 2, like when you will take the OR of first two number, it will become 0, 1 and 2. This becomes OR of 0, 1, 2 and 3, like if you see all the three numbers. And the third number becomes like OR of all of these numbers. And this number becomes all of number here and OR of number here. So the number will be, and so on. So like essentially what I am saying is at mth instant, an would be like bitwise OR of all the numbers which are in range n minus m to n plus n. Careful of the negative numbers here, like we don't have to include the negative numbers. Okay, any questions on this one first? So like once we know like this thing, so our problem boils down to given L and R, Find bitwise OR of all numbers in this range. Like there are many ways to do it. And like one thing which I will do is probably like one thing we can probably do is like let's look at the number like how do I define it? Like let's define L2R. My wait. Like the problem, like all of the problems I felt were definitely harder than the normal. Like I even felt like problem A is harder for its range. How do we define L2R? So yeah, one possible way is like let's assume that we have a segment tree of range from 0 to 2063, where 2063 is open segment tree. Like we don't have to create a vector of this size, but let's assume we have a segment tree of this much range. Then like on the first instant, like this segment tree will change from 0 to 2 to the power 62 minus 1. And like this will change from 2 to the power 62 comma 2 to the power 63 minus 1. We can even split it further. 0 to 2 to the power 61 minus 1, 2 to the power 61, comma 2 to the power 62 minus 1, 2 to the power 62, 2 to the power, like here the number would be 3 times 2 to the power 61, 2 to the power 62, comma 3 times 2 to the power 61 minus 1, and 3 times 2 to the power 61, and 4 times 2 to the power 61 minus 1, and so on. Like basically, like if we assume that we have a segment tree, zero and 2 to the power 63 minus 1, like you also, or probably I can represent it as a half open interval. And at each range from L to R, we split midpoint as L plus R by 2, and like the left child becomes L to M, and right child becomes M plus 1 to R. Then at any point of range, like at any segment in this segment tree, any node with range L to R, like OR is just OR of two endpoints here, nothing more. Like the other way to visualize, like I will probably share some visualization here. Like we have 0, 1, 2, 3, 4, 5, 6, 7. This is the base level. When you merge node here, 0 to 1, 2 to 3, 4 to 5, and 6 to 7. The one at the top would be like 0 to 3, 4 to 7. And here I can probably write 0 to 7. Like you can see, like at any point of node, like the OR is basically the right hand point here. All of this number is 0, all of these two numbers is 1. OR of these numbers is 3, OR of these numbers is 5, OR of these numbers is 7. OR of these numbers is 7, OR of these numbers is 3. And OR of these numbers is 7 and so on. And essentially like that is what we can do. And like one of the comment is I don't know segment trees. Like probably like I would say like this is the first data structure which should learn, and I'm assuming you are just starting out. So like it never hurts to start learning things here. Like I can give some guide for the segment tree, what you can use to read. Segment tree, segment tree. Mm-hmm. I'm assuming like this book has a segment tree. Yes, segment trees are there. So like you can probably use this book to learn over here. And like probably this is the simplified solution I can present for this case over here. And like I will probably jump onto code as well. Where is problem B? Where did my text editor go? So like I have taken this N as M as input, and like what I need is OR of range from n minus 1 to m to this range over. Like I have taken max with 0 because I don't need negative OR. If I am outside the range, and if everything is between the given range, L and N, like this is probably one of the solutions here. And looks like some people have an easy solution, like probably in the chat, like probably can someone say like whose solution is easy to understand over there? Like I can probably take a look at it and try to explain those easy solutions. But segment tree idea like probably makes life easy over here. Like this is again like the segment tree idea only, nothing more. Like boils down to segment tree. Like, this is probably jumping the same part. Jingly, where is okay? Like jumping solution is essentially what I see like another way to implement segment. The one which we saw. Earlier. Okay, what Jingly is doing is like we again have a range from L to R. If ith bit is not on, like he's basically jumping, like to be honest, looks more complex. Like what I can do is I can probably check editorial as well. What do they have? Not really sure. Like, probably like any other simple ideas if someone has in the chat. Like otherwise, I will just keep the segmentary one and move to the next problem. Okay, one idea which we can see probably try to do in solution was okay. Like I will probably move to the next problem. Definitely not a newbie friendly solution, but essentially that's what I have. And like probably problems were definitely like I was off on all the four problems there together. Like I found B easier than A. I ended up resubmitting A later, only to realize 2 less than R is given. Like B was also an overkill, and like C and D like looks the same. Like I got AC on last 10-20 minutes. Okay, turtle and incomplete sequence. Turtle was playing with the sequence A1 to A consists of positive integers. Unfortunately, some of the integers went missing while playing. Now the sequence becomes incomplete. There may exist an arbitrary number of indexes I such that AI becomes -1. Let the new sequence be AI dash. Turtle is set, but turtle remembers that for every integer I from 1 to n -1, either like AI is half of AI plus 1 or AI plus 1 is half of AI. Holds for the original sequence A. Formally, you need to find a sequence B1 to Bn consists of positive integers. This like basically we have to replace -1 with some any value we want, such that for every consecutive pair of integers, one is half of the other number. And if no such sequence exists, we should print -1. And essentially, like this is a solution. This is the problem statement. Any questions on the problem statement? Like any questions on the problem statement of problem C before we move to the solution? Okay, like probably like the idea I had was like there will be some sequence of -1s. Like we have some numbers like and like we have some consecutive -1, then some another number is there. And like so basically like we can say like there would be some prefix -1s, and there would be like if all the numbers are -1, then we can replace it with 1 to 1 to 1 to 1 to, and we are done with it. Otherwise, like the sequence will look like this. Where like circles are the number which are not -1, and like this would be some range of -1. My idea is like here like we can definitely fill number without any contradiction. Like we can take like if this value is AI, we can take AI by 2, AI by 4, and so on. And if 1 comes in, then we can replace it with by 2 and we can be done over here. And similarly, we can do for the right hand side. We have some number here. We can replace, we can keep dividing by 2, and once we reach 1, we alternate between 1 to 1 to 1 to, and we can fill all the numbers here. So these numbers are not a problem. The problem can be this range, like where like there can be no way to fill numbers here. So what I will do is, like, we have some AL, we have some AR, and then we have some bunch of -1 here. My idea was, like, if AL is greater than AR, replace here with AL by 2, and if AR is greater than equal to AL, replace this number with AR by 2. And like we can keep doing it, like look at it as like we have 2 pointers, left and right. If left side is greater, replace the next number of the left side with that number by 2. If right side is greater, replace that with right side by 2. And if both the sides are number 1, then you can fill the number 1 to 1 to alternatively between them. And like that way, I will first fill the complete sequence, and then I will check if this is a valid sequence. If it is a valid sequence, I will print that whatever sequence I got. Otherwise, I will print -1. And like we can probably try to prove that if there exists an answer, then this way of giving answers will also give us an answer. And like that is the solution over there. Like PVR IDX, like, and I'm iterating from all the numbers. If current number is R, otherwise if current number is not equal to R, then I will say fill segment this. And like I have a left point endpoint, I have a right endpoint, and I have a function which takes value x and returns me half of it. And if the value is 1, then it will it returns me 2, and like that's the only corner case. If the left endpoint is 1 and right endpoint is n, it means all the numbers in the given sequence are -1. So what I can do is I can fill it with an alternate sequence of 1 and 2 and get away with it. Otherwise, if L is equal to -1, like I can fill the same sequence again, like keep dividing by 2, and once you reach 1, you alternate between 1 and 2. Or if I am on the other endpoint, fill this and return over there. Like A and AL are already filled. So as long as the sequence have at least one number in between them, if AL is greater, fill like this AL plus 1 and L plus 1. Otherwise, like fill R -1 and move back to the reverse side. And like this is my way of filling the numbers. Like we are comparing both pointers every time we divide by 2. Like we have 2 pointers, whichever is higher, we fill the next number of that pointer in that range. So if the last number is higher, we fill the second last number by 2. If the first number is higher, we fill the second number by 2. Like this way I will fill it. Now I have to check if the number is valid or not. Like if the first number is valid, it's fine. If the second number is valid, is also fine. Otherwise, it's valid is 4. And if its number is not valid, 3 out minus 2. Otherwise, print like whatever sequence we have got, and essentially like that was the solution I had for this problem. Okay, like how do you prove this solution is correct? So like one way, like the vague idea I had was like I can look at the maximum power like log of r over there. Then if you divide by 2, that log value increases by 1, otherwise that log value decreases by 1. So like if you replace AI with log 2i, then at every instant like either the value should increase by 1 or the value should decrease by 1. And like this gives us an intuition like what we can do is like we have two numbers, let's say 5 and 10. Then we can first try to subtract to make them closer to 0, and then we can remain constant at 0 1 over there. And like that was the intuition I had for solving this problem. And instead of going towards 0, like we can also fix the upper bound, like let's say we will go up to 60 and then we will remain at plus minus 60, and that idea will also work over here. And like the only problem is when you increase the number, you have a range over there. Like for example, if you have number 5, then 11 by 2 and 5 by 2 is 11 by 2 and 10 by 2 are both 5. But if you go down, then 5 by 2 is 0. And like that's why like it's always fruitful to go towards 0 1 rather than going down. Like internet is becoming a bit tricky. Like is Codeforces down or is it just mine? Okay, yeah, I see. Any questions on problem C before we move to problem D? Sir, how do you think of this idea? Like, have you seen it before or it was dry running? Like, I'm not sure if I have seen it before, like, but like when I saw like I can write each number as log I, and that operation is essentially doing plus one minus one over there. And like that's when I realized like we can go to 0 and then we can keep oscillating over there. Okay, problem D. Turtle and multiplication. Turtle just learned how to multiply two numbers in his class and he was very excited. Then Piggy gave him an integer n and asked him to construct a sequence a1 to an consists of integer which satisfies the following condition. Like each AI is between 1 to 3 e5, and for any consecutive pairs, like none of the pairs have the equal value. Turtle definitely could not solve this problem, so please help him find. And it says for any such sequence, Turtle needs to find which are minimum number of distinct elements there. So like the idea is like let's say we have k distinct numbers. What we can do is like we can choose k largest number in range like 10 to the 3 into 10 to the power 5 minus k to 3 into 10 to the power 5. This can be one way. Like, let's first assume that we have k different numbers. Like, then like what are the possible values we can choose? If we choose k distinct numbers in this range, then if you choose any two number over here, like the product will always be a distinct number over there. Or like the other way can be like you can choose k prime numbers. Then if you look at pairwise product of all of these numbers, like you will always have distinct prime number. So what it remains is distinct number such that any pair, all ai and ai plus 1 pairs are unique. Makes sense, right? Like the unordered pair. So like if we can try to find the numbers like this, then later on we can replace it with all the prime numbers. Like for example, like we take numbers from 0 to k minus 1 and we can replace like 2 with, like if we take like first we create a sequence like this where each pair is different number, then like we can replace with fifth prime number, or we can replace with 10 with 10th prime number, and like the product will always be unique if all the pairs are unique. And the next thing to look at was like any questions on this one so far? Like why I am focusing on like each pair of consecutive numbers, not the product? Like how if I can create a segment where the product is different, then I can also like where each pair is different, then I can also create the product different. Like any questions? Like what we have to do is like we have to find a sequence which has numbers from 1 to k and value of k is minimum possible. And if you look at each consecutive pair, the unordered pair of those numbers is a unique number. Okay, then I will move to the next idea. My idea is like let's look this number as a graph. And like there is an edge between each pair of numbers here. One is connected to all, two is connected to all, one, two, three is connected to all, one, three, two, four is connected to all. Yeah. So the idea is like if I can find a unique walk over here where like I don't repeat, can find a path of length n minus 1 where no edge is repeated, then I can use that path as answer. Makes sense, right? Like if I have k nodes, then I create a complete graph of k nodes, so like where all the pairs are connected with each other. Now in this path, like I start from some node and I have to find a path of length n minus 1 so that there are total n nodes. And if we do not repeat an edge, then none of the consecutive pairs will have same product over there. And like that was the idea. And like if k is odd, each node has even degree. Also, one thing to note here was like one self edge is also allowed here. So like Eulerian path exists. So like when k is odd, like there definitely exists a path which can travel through all the nodes over here. And essentially like this is what I was googling in the conversation. Like there is a solution over here, like how to find a path. As if k is odd, then each of the node has even number of edges, ignoring the self edge. So what I can do is like there definitely exists a path which starts from one node, moves through all the edges and comes back to that node. And if k is even, so for 5 nodes, there are 5 into 2 by 5 into 4 by 2, which is 10 edges plus 5 self edges. So like we can definitely find an array of 16 value using at most 5 distinct nodes. Or if you have 11 distinct nodes, we can definitely find one array with 11 into 10 by 2, which is 55 edges plus 11 self edges, 62 edges. So total 67 nodes can be found. And similarly, let's say if we have 12 nodes, what we can do is we can first find the path for 11 nodes, and then we can insert number 12 in between some points. Like for 11 nodes, like we would be able to insert between 5 pairs. Plus we can add it at last. And like we can also have a cycle from 12 to 12. And essentially like it boils down to like reducing the finding the Eulerian cycle over here. And like that was the solution I had. First I ended up hard coding, like I have get count function which finds like how many nodes I can have. Like if there is one node, like I can just have array of size 2. If I have 2 nodes, I can have array of size 3. If k is odd, like these are the other edges I can have. I can also have k self edges. So like the maximum path length I can have is edges plus self edges. Like let me write it as a separate function. And if k is even, then I can first find the graph using k minus 1 nodes. Now like I can insert it between k by 2 different pairs in between. And I can also have like this would be the number of pairs where I would be able to insert in between. And like I can also insert one at last, and I can also have one for self. And essentially like this is the solution idea I had for this one. That way, like I can first keep on increasing k to find the maximum possible value I want. Like when I'm printing, like I can just print like, and like that should be fine. If k is 1, this is my hard-coded answer. If k is 2, this is my hard-coded answer. If k is even, like I first find the answer for k minus 1 nodes. Then I will insert k minus 1 in between. First, I can remove like the last node so that I know like I will insert once at the last over there. And like I also allowed one j equal to k minus 1 for the self edges. I start with the first node and like I keep on adding nodes over here, like my previous node, my current node. If I have not added pair with the previous node and the current node and both of them are unequal, so like I can insert it between these two nodes. And I can remove these nodes where the insertion would be allowed. And at last, I can insert 2 times there. And like probably if k is even, like my get path is the method which will find the maximum possible length of array using k. And now coming back to like how do I find it? Like this is the algorithm for. Where like k odd is given so that each of the nodes have an even nodes. I first create all the edges. And the idea is like finding like an Eulerian path is a graph that passes through all the edges exactly one. A Eulerian cycle is a path that is a cycle, like basically it starts and ends with the node. And it says like the algorithm to find this procedure is we have the recursive function find Eulerian path, iterate over all the edges outgoing from V, remove this edge from the graph and call like the method from the subsequent edges. Like the idea is really like you are at a particular node, find one of if all of them have even edges, then like even degree, then what you can do is like you can find any of the random neighbor which has not yet been picked up. You push this edge in your path and you move to the next node and you keep doing it. At the end, like you will definitely come to the starting node. Like let's make it a bit. Like I have created this graph, which is complete graph. Like this is the maximum length I would be able to get it. Or probably let's say like as long as like current node is not an empty node. Like remove and if current is not equal to next, then also remove it from the other list. Like push current node in your path and essentially like this is the algorithm. And at last you can assert that you will reach back to node 0. And like this was the solution I had for the like, and it did took me quite a long time to get all the details right. So any questions on this one? Like, to be honest, like the explanations were definitely not beginner friendly, and that is because probably like I did not found the problems easy, to be honest. Like B was the first problem I submitted. A took me quite a long time. Then I thought my solution is probably wrong, so I ended up resubmitting it. Then I realized 2L is R, 2 times L is less than R. Like B was definitely something not at all easy for the problem B as well. Like D definitely took less submission, but it did took quite a long submission. Similar was the case for C also. So like any questions on like probably a runtime error? Mhm. Like where did it fail? Like any idea? Okay, the problem with runtime error is we can't even. It looks like I matched up with that count somewhere. Okay, like my idea was like first if self has exists, just go through self has. Or like I am probably messing up with that count. Maybe. Mhm. If case or like these are the pairs together, these are the number of self edges we can have. One second. Hello, hello, hello. Okay, looks like I matched up with edges on. Like why do I have empty edges here? Okay, and looks like get count is wrong somewhere. These are the number of pairs. These are the number of self edges. Looks fine, right? Okay, I forgot to count probably one was short path. Like, let me just pick up my in context submission and see like, where I'm making the that count for 39. 781 only. 781 looks fine. Like looks like I'm making a mistake counting something. Like when k is odd, when k is odd, k into k minus 1 by 2, k into k minus 1 by 2, plus 1 plus k, right? From overloading like that. So essentially, like this was the solution from A to D. Any questions on this? The critical piece was like if there are odd number of distinct numbers, then like we can use the Eulerian finding algorithm to ensure that every pair is there. And when there are even number, like we can find like complete node for the just one, and we can try to create as many pairs as the last one. I will probably not debug it further, but essentially like you can read the code here that does the same thing. If k is odd, these are the number of pairs, these are the self edges, and this is the total. And if k is even, number of nodes, number of pairs for the just minus one, number of self edges, one extra for the path, and the number of pairs you can form over here. And it runs in 199. And essentially, like these are the solutions for A to B. And in D, probably my idea, like I will probably leave it for today. And like I think with this I will probably end the stream today. Any questions related to the contest or anything else before we call it a day today? Like, my plan was to discuss even the problem E, but like there are still issues in the problem. Okay, like I think with this the stream is mostly over. Like I will probably take 10-15 minutes, and if I end up solving problem E, then I will probably try to explain the solution, otherwise it's fine. Mhm. No, like probably like I will just leave it here. Can C be solved using BFS? Like how do you define BFS? Like what kind of solution for that? Like editorial is also out. Like let me just see like my prediction for the solution of E. Like within 5 minutes, like last 5 minutes, I ended up writing like Grudka's algorithm might work here. But then I tried for an hour and I did not. Okay, first it says stop thinking about this algorithm. Okay. Like I was completely off. Like I was trying this algorithm first and says don't try it. Like I think this closes. Reaching from one value to other, all the values in between are -1 through x and x by 2 and 2x. Like the problem I see is like for BFS, like you will probably visit each node only once over there. So and like the number can be very large, right? You might want to maintain some range of numbers which you will be able to do it, and then the construction will become hard. And moving from left to right was essentially kind of doing BFS only. So like you will end up getting a bunch of numbers that is possible to reach over there and not really sure what they will do. So like just 4 problems for today, and like I definitely felt the problems were hard, but let's see. So thanks everyone for joining today, and like I will end today's stream now. So thanks a lot everyone for joining.